Chapter 13 of our astronomy book went over the Kuiper Belt and dwarf planets. And so I thought it would be a good idea to go ahead and start with the Lesson 13 study guide. And it reads, the Kuiper Belt is named after astronomer Gerard Kuiper. In 1951, he predicted the presence of a belt of icy objects beyond Neptune that would explain some mysteries about comets. The belt is very similar to the asteroid belt, except that the objects in the Kuiper Belt were usually larger and mostly made up of ice, not dust. Scientists think the Kuiper Belt is a source of our solar system's short-period comets. The Kuiper Belt also includes many dwarf planets. I'd like to stop for a moment and mention that there was a mystery as to where short-period comets came from. Many scientists that are not Christians believe that the universe has been around for billions of years. And if the universe has been around for billions of years, a comet is a problem because comets, every time they come close to the sun and we're able to see them up in the sky, part of the frozen gases that are in the nucleus of the comet melt away every single time it goes past the sun. And so if the universe has been around for billions of years, short period comets should not exist anymore. They should have all melted away millions of years ago. Gerard Kuiper suggested that perhaps these short period comets had a place that they were coming from. So he suggested that beyond Neptune there may be what he called like a birthplace for short period comets. Scientists who aren't Christians don't have as much problems with long period comets because they don't come close enough to the sun often enough to have melted away, at least in theory. Now, creation scientists have no problem with short period comets because they believe that the Earth is a lot younger, and so comets that God created at the beginning of time to be signs for people in the sky, just as he promised in the book of Genesis, would not have had enough time to have melted away over the course of 6,000 to 10,000 years, which is what many creation scientists believe, that the universe is 6,000 to 10,000 years old. We'll move on with our study guide now. The International Astronomical Union defines a dwarf planet as a heavenly body which orbits the sun, has enough mass to assume a nearly round shape, is not a moon, that means it doesn't orbit another planet, and has not cleared the neighborhood around its orbit. Recall that the International Astronomical Union needed to come up with a definition of a dwarf planet after an object in the Kuiper Belt was found that was actually larger than the 9th planet at the time, Pluto. Many astronomers had objected to including Pluto as a planet to begin with, and so the discovery of Eris in the year 2005 opened this debate up whether Pluto should actually be considered a planet, because Eris was actually rounder than Pluto and it was slightly larger than Pluto. Remember at the beginning of the year we discussed that some people call it potato-shaped, but it's mostly round, and we'll be looking at pictures of Pluto in just a moment so that you can see that Pluto is mostly round, but it's not an exact sphere like Jupiter, like Mars, like the Earth is. The primary difference between a planet and a dwarf planet is that planets have enough gravity to pull tiny space objects into its atmosphere and clear its orbit of debris. Dwarf planets do not have enough gravity to clear their surrounding area or neighborhood of space debris. There are 5 recognized dwarf planets, but scientists believe that there are many more to be discovered. Ceres is a dwarf planet that was discovered in the asteroid belt. It was classified as an asteroid until 2006, when scientists decided it fit the definition of a dwarf planet. Ceres is round and smaller than Earth's moon. Scientists believe that Ceres has an atmosphere. A day on Ceres lasts 9 Earth hours. It takes Ceres 4.6 Earth years to circle the sun. The average temperature on Ceres is 158 degrees below zero. Pluto was considered the 9th planet in our solar system until 2006, when it was reclassified to a dwarf planet. Pluto is smaller than our moon, and one other dwarf planet is larger than Pluto. Pluto is believed to have an atmosphere made of methane and nitrogen. A day on Pluto lasts 153 Earth days. It takes 248 Earth years for Pluto to orbit the Sun. Pluto has an average temperature of 400 degrees below zero. Pluto's orbit is tilted. Scientists have discovered that Pluto has 5 moons. The largest is Charon, and it's about half the size of Pluto. Eris is a dwarf planet in the Kuiper Belt that's larger than Pluto. The discovery of Eris is what triggered the debate in the scientific community that eventually led to the International Astronomical Union to define what a dwarf planet is and to rename Pluto a dwarf planet. A day on Eris lasts about 24 Earth hours, and it takes 557 Earth years for Eris to orbit the Sun. Like Pluto, its average temperature is 400 degrees below zero. Makemake is a very small dwarf planet in the Kuiper Belt, smaller than Pluto. It's so far away that it has not been studied much. Scientists think a day there lasts 22.5 Earth hours, and it takes 310 Earth years for Makemake to orbit the Sun. It's the second brightest Kuiper Belt object after Pluto. Haumea is an egg-shaped dwarf planet in the Kuiper Belt. It has 2 moons orbiting it. A day on Haumea lasts 3.9 Earth hours, and it takes Haumea 283 Earth years to orbit the Sun. Because it's so far away, it has not been studied very much. There are currently 5 known dwarf planets. Ceres is the only known dwarf planet in the asteroid belt. The other 4 dwarf planets are in the Kuiper Belt, though Pluto orbits the Sun with a tilted orbit. All the dwarf planets are smaller than Earth's moon. The smallest dwarf planet is Ceres, and the largest is Eris. Remember that Pluto was the god of the underworld in Roman mythology. Pluto was also the god of wealth because diamonds and other jewels came from underground. He's usually depicted with a bident, which is a 2-pronged staff, and a 3-headed dog. Ceres was the Roman goddess of agriculture. Her daughter Persephone was Pluto's wife, and she's depicted with a sheaf of wheat or a cornucopia. Since we read about the origin of the names of the dwarf planets Pluto and Ceres, I thought it might be interesting to also give a little information about the names of the dwarf planets Makemake and Haumea. Makemake is the name of the creator of humanity and the god of fertility in the mythology of the South Pacific Islands of Easter Island, and Haumea is the guardian goddess of the island of Hawaii. She's identified as the goddess of the earth and the wife of Wakea, the god of light and the heavens. And so you might be wondering, why in the world did they choose Hawaiian names or Polynesian names for the gods, goddesses that they named these particular dwarf planets after? And the reason is because both of these dwarf planets were discovered by a team of astronomers that were working at the Gemini Observatory North, which is located on Mauna Kea, Hawaii. I'm assuming they decided that they wanted to honor the false gods and goddesses that had been worshipped by the Polynesian people, including the Hawaiians, when they found these dwarf planets and named them. As part of your homework this week, you were supposed to fill in a chart that located the positions of the 5 dwarf planets that we studied in this particular chapter. So remember that we have the 4 inner planets. They are Mercury, Venus, Earth, and Mars. And the inner planets are separated from the outer planets by the asteroid belt. The 4 outer planets are Jupiter, Saturn, Uranus, and Neptune, and they are surrounded by the Kuiper Belt. Remember that the dwarf planet Ceres is the only dwarf planet that is located in the asteroid belt, and until the year 2006, it had been classified as an asteroid. Pluto is the most famous dwarf planet, and notice on this diagram that Pluto's orbit around the Sun is very different from everything else pictured in the diagram. It's kind of skewed up. Also, Pluto's orbit is highly elliptical. That means it's not an actual circle, that it's more like an ellipse, a stretched version of a circle. Sometimes Pluto is actually closer to the Sun than Neptune is, and sometimes Pluto is further away from the Sun than Neptune is. Eris is the dwarf planet that was discovered in 2005 that was actually larger than Pluto. Makemake is a dwarf planet that was discovered in 2005 also. and little Haumea, who was actually discovered in 2003, but was not considered to be a planet or a dwarf planet because it's so much smaller and it's not round at all. But after the discovery of Eris, in the debate that followed, scientists decided to designate Haumea as a dwarf planet also. I thought we would look at some pictures of the dwarf planets. Here is one view of Pluto, and here's another view of Pluto. And you'll notice that depending on where the photograph is taken of Pluto, that it looks rounder or it looks less round. We would say that Pluto is mostly round. It's not a perfect sphere like, for example, Saturn or Jupiter or Mars or Earth is. Here is a photograph of Ceres. Notice that it's also not a perfect sphere, but it is fairly round. Notice also how pockmarked it is, and that's because Ceres is located in the asteroid belt, and you can tell that it has been hit many times by flying debris within the asteroid belt. As we move on to Eris, I'm pretty sure that we no longer have photographs of them. This is an artist's depiction of what they think Eris looks like based on the best scientific information they have. They know that Eris is very frozen and cracked looking based on the best scientific knowledge that they have right now. When we have a spacecraft that actually is able to get close enough to Eris and take photographs of it, our image of what Eris looks like may change. The same with Makemake. This is actually an artist's depiction of what they think Makemake looks like. Notice it looks more perfectly spherical than Pluto or Ceres does. And once again, that's because this is an artist's imagining of what Makemake looks like. And the same with this picture of Haumea. They know that Haumea is egg-shaped, but how the surface of Haumea looks, we aren't quite sure. And so this is an artist's depiction based on the best scientific evidence that we have now. And when we're able to send a spacecraft closer to take pictures of Haumea, our ideas about what Haumea looks like will probably change. Activity 13.1 asked you to make two models of dwarf planets. One was supposed to represent a dwarf planet that was closer to the sun, and the other one was supposed to represent a dwarf planet that was further away from the sun. Remember that the point she was trying to make was that dwarf planets that were close to the sun were usually smaller and had less ice than dwarf planets that were further away from the sun. And so when we did this experiment at home, I went ahead and took a picture. You'll notice that both of our models are very irregular in shape. Neither one of them are particularly round. I guess the one that is larger looks rounder than the one that's smaller. Also note that you can see the rocks and the dirt very clearly in the model of the smaller dwarf planet, and it's more difficult to see where the rock is in the model of the larger dwarf planet. One of your homework assignments this past week was to fill in a chart with the similarities and differences between the Earth and dwarf planets. And so I thought that we would go over this together. Don't worry if you don't have everything that I have on there, although it might be a good idea in studying for your test to go ahead and fill in some information based on what we go over right now. So we're going to start with the similarities. First of all dwarf planets and the Earth orbit the sun. Remember that we call a full orbit around the sun a year. Both the Earth and many of the dwarf planets have moons. Not all of the dwarf planets have moons, though. The Earth and dwarf planets are somewhat round. The Earth is more perfectly round than many of the dwarf planets are, however, and that's why I put round in quotation marks. They're sort of round. The Earth and the dwarf planets are terrestrial. Remember that terrestrial means Earth-like. There are rocks there. There's dust there. Maybe not dirt in particular, but definitely dust. They are not gaseous like the gas giants. Many of the dwarf planets have craters where they've been hit by meteoroids or other asteroids in the case of Ceres. which is in the asteroid belt. And the Earth has been hit by these things also. And so we have some craters on the Earth and on these dwarf planets. Both the Earth and the dwarf planets rotate. Remember, a full rotation is what we call a day. And some of the dwarf planets actually have an atmosphere. All of these objects also have gravity. Of course, the Earth is much larger than the dwarf planets, and so it has a lot more gravity than they do. Going on to the differences, remember that many of the dwarf planets have irregular orbits, most famously Pluto, which has more of an elliptical or an elongated circular orbit rather than a nice circular orbit. Some of the dwarf planets have irregular shapes, most notably Haumea. The dwarf planets have not been able to clear their neighborhood because they don't have enough gravity to do that. The atmosphere on dwarf planets that have one are not breathable. They're primarily made up of gases like methane. The dwarf planets are a lot colder than the Earth is because they're so much further away. There's no liquid water on any of the dwarf planets, and the gravity is smaller. In addition to the chart, there were 3 questions that we had to answer. Remember that this chart was a translation of Activity 13.2. Activity 13.2 listed 5 questions, not just 3, but the first 2 questions I felt like were already answered by filling out the chart. Question 1 was, how are the Earth and the dwarf planets similar? And question number 2 was, how are the Earth and dwarf planets different? If you filled in the chart, then you've pretty much already answered that question. So I went ahead and wrote down questions 3, 4, and 5 from the book on page 174 as question 1, 2, and 3 on your worksheet. So question 1 on the worksheet, are there similar characteristics between the 5 dwarf planets? If so, what are they? They all orbit the sun, they all have craters, they are terrestrial, and they all rotate. That is, they have a day. They spin around. Number 2 asked, do you believe people could live on a dwarf planet? Explain your answer. And so, since this is your opinion, I'm not going to say, this is the right opinion, this is the right answer. Hopefully you filled that in, and when you turn your homework in January, when we get back together, I'll look over that, or Mrs. Pack will look over that. Question number 3 said, which planet or dwarf planet has the most moons? Pluto has the most, it has 5 moons, and then Haumea has the second most with 2 moons. Since we asked the question about the moons, I thought it would be interesting just to look at some pictures of the moons that we know of that are orbiting these dwarf planets. Of course, Pluto is probably the one that has been studied the most, and Pluto has 5 moons. Remember that Pluto was the god of the underworld in Roman mythology, and so when scientists were naming the moons around Pluto, they decided to choose names that went along with the character of Pluto in the mythologies. Charon, remember, is the largest of Pluto's moons. In mythology, the name was not pronounced Charon, it was pronounced Charon. Charon was the ferryman who conveyed the souls of the dead across the river that separated the land of the living from the land of the dead. Styx was actually the name of that river. It was the river in the underworld over which the souls of the dead were ferried by Charon and by which the gods swore their most solemn oaths. Nyx was the Greek goddess of the night. She was actually the personification of night. Cerberus is named after the hound of hell. In English, we sometimes pronounce that animal's name Cerberus instead, spelt with a C. Remember that Cerberus was the 3-headed dog that guarded the gates of the underworld so that the dead couldn't come back out from it. And finally, Hydra was a many-headed serpent or monster in Greek mythology that was killed by Hercules. Remember that the story was that every time Hercules cut off one of its heads, 2 heads would grow in its place. And so in order to kill the monster, he had to be able to sever all of the heads at the same time so that there wouldn't remain any life in it at all, and it wouldn't be able to regrow. The moons of Haumea are named after other Polynesian or Hawaiian gods. Hiaka was the daughter of Haumea, and she's famously known as being the youngest and the most favored sister of Hawaii's volcano goddess, Pele. Namaka is another daughter of Helmea. She's actually the goddess of the ocean. And according to mythology, she got into an argument with another one of her sisters, Pele. Remember, she was the goddess of the Hawaiian volcanoes. When Namaka's husband decided he wanted to leave her and instead marry Pele. And so according to the mythologies, Namaka sends a tidal wave trying to destroy the Hawaiian Islands. The dwarf planet Eris also has a moon. It was named Dysnomia. Now, Dysnomia is the name of Eris's daughter. Eris was the goddess of arguments and discord in Greek mythology. The name of Dysnomia actually means lawlessness, and so it should make sense to you that the goddess of discord would have a daughter who was lawless. Finally, I'd like to go over the answers to the what do you remember questions. The first question asked, what is the Kuiper Belt? Remember that the Kuiper Belt is a belt of icy objects orbiting the Sun past Neptune. What is the difference between a planet and a dwarf planet? Dwarf planets don't have enough gravity to clear their surrounding area of space clutter. Why do we use spacecraft to study the dwarf planets? Because our telescopes cannot see the planets very clearly from Earth, while a spacecraft can pass by the dwarf planet very closely, take pictures, and measure scientific data, for example, how cold something is, and what actually makes up the surface of the dwarf planet. It can also discover what gases are in the atmosphere of a dwarf planet if the dwarf planet has an atmosphere. That's our review for today. Good luck on your quiz.